Hi everybody. In this part of lesson 1-6, we're going to focus on subtracting like mixed numbers. Here's a sample problem. After you hear it, I want you to pause the presentation, take a second and talk with the people around you to see if you can figure out how you'd go about solving this. I have 3 5/6 yards of string. I cut off 2 1/6 yards of string for my sister. How much string do I have left? Pause this now and see if you can solve. Okay, you should have paused, and now that you're back, let's see what we've got. 3 5/6 yards of string. Since we're cutting off 2 1/6 yards to find out how much is left, I know that this is subtraction. 3 5/6 minus 2 1/6. Hopefully you realize that we can solve this just like we did the addition. Subtract the fraction part, 5/6 minus 1/6, which is 4/6, and then subtract the whole numbers, 3 minus 2 is 1. Now I know that that can be simplified as well to 1 2/3 yards of string. Try another one, 4 7/8 minus 2 3/8. Pause the presentation, try and solve this problem and see if you can get the right answer. As soon as you're done, resume the presentation. So we had 4 7/8 minus 2 3/8. Just like before, we'll start with the fraction. 7/8 minus 3/8 is 4/8. And 4 minus 2 is 2. Simplify to 2 1/2. Hopefully, you came up with that answer with your group or your partner or on your own. If not, maybe it's time to pause the presentation, rewind, and go back to see how I did that. Let's look at one that's a little bit more difficult. What if we had 7 1/5 minus 2 4/5? When I write that, 7 1/5 minus 2 4/5, we run into a problem. We read math problems just like we read a book from top to bottom. So if I start with the fraction part like I'm supposed to, I've got 1/5 minus 4/5. How would we go about doing that? I'd like you to pause the presentation, talk to the people around you. Think back to earlier grades when you first started subtracting and you ran into a problem similar to this one. The number on the bottom was smaller than the number on the top. What did you do then, and how might you do something similar, not exactly the same, but something similar to help you be able to solve this problem now? After you've talked with your neighbor or your group, come back to the presentation and see if you were able to figure that out. Okay, so we had 7 1/5 minus 2 4/5. I hope you talked with your neighbors and realized that because you have 7 whole, you could take one of those whole numbers and trade it in for some more fifths. 1 whole is equal to 5/5. So if I take 1 whole from 7, that leaves me 6. If I trade that in for 5/5, I would end up with 5 more fifths than I originally had, which was just 1. 1/5 plus 5/5 is 6/5. Now I've got enough to subtract. 6/5 minus 4/5 is 2/5, and 6 minus 2 is 4. So our total comes out to 4 2/5. So there's 3 ways to subtract mixed numbers. We can ungroup, we can add on, or we can convert to fractions. Let's dig into each of those. You actually already saw number 1, which was ungrouping. So one more time, just in case you didn't catch it the first time around. 7 1/5 minus 2 4/5. We read fraction problems just like a story from top to bottom. I can't do 1/5 minus 4/5, so I go next door to the 7, the whole number. I'm going to borrow 1. That leaves me with 6 whole. I know that I have to trade it in for the size of the fraction that I need, which is fifths, and 1 whole is equal to 5/5, so I would have, 6/5, because 5/5 plus the 1 I had is 6/5. Now we can subtract. 6/5 minus 4/5 is 2/5. and 6 minus 2 is 4. Another method we can use is called add on. This is using a number line or picturing a number line in your head and solving these mentally. Remember, subtraction is nothing more than the distance between 2 points on a number line. So I would want to find the distance between 2 and 4/5 and 7 and 1/5. I am going to use stopping points in between these two numbers to solve this quickly and oftentimes in my head. The whole number that comes after 2 and 4/5 is 3. So I'm going to start there. And I know that the whole number that's before 7 and 1/5 is 7. So these are the only points I need to add to my number line. Now we're going to find out how much it takes to go from 2 and 4/5 to 3. Since 3 is the next whole number, and I know that there's a total of 5/5 between 2 and 3, and I've already got 4 of those fifths, it would only take one more fifth to go from 2 and 4/5 to 3. To jump from 3 to 7, I know that 7 minus 3 is 4, so that would be a total of 4 jumps. And finally, to go from 7 to 7 and 1/5, I'm just adding one more fifth, so the distance here is 1/5. The last step to solve this is to add all of the pieces. 1/5 plus 4 plus 1/5. You can add those in any order. I've got a whole number of 4 plus a fifth and a fifth, which is 2/5. The last way that I'll show you is to convert to fractions and then subtract. This was similar to when we were adding like mixed numbers. 7 and 1/5 minus 2 and 4/5. To convert to fractions, remember you can make a mixed number mad. Multiply, add, denominator doesn't change. Multiply, add, denominator doesn't change. So for the top one, we would do 5 times 7 plus 1. 5 times 7 is 35, plus 1 more is 36. For the bottom fraction, 2 times 5 is 10, plus 4 is 14. And now we can subtract. 36/5 minus 14/5 is 22/5. Now you need to go back to a mixed number, and to do that, remember a fraction bar means divide. 22 divided by 5. 5 goes into 22 4 times. 4 times 5 is 20, and when you subtract, you get 2. This 2 becomes the numerator, and your divisor of 5 becomes your denominator. So that's 3 different ways of solving these subtraction with like mixed number problems. They're all going to be correct. It's just whichever one you're most comfortable with, and eventually which one is the most realistic to use in a quick way. Here's 3 more examples. I'd like you to pause the presentation, work with the people around you to solve these 3 problems in your math notebook, and then come back to the presentation so that we can check them together and see how you did. Okay, now that you've had a chance to pause and try these problems out, we're going to start with the first one, 2 minus 1/3. When I set that up, I have 2 whole and I'm subtracting a fraction. Just like place value, we want to line up the fraction part with the whole number part. So I have no fraction, so the 1/3 is under nothing, and I have no whole number in the bottom, so there's nothing under the 2. I'm going to ungroup because that's my favorite method. I have no thirds to subtract 1/3, so I'm going to borrow 1 from 2, which leaves me with 1. I'm looking for the size of the fraction that I have to subtract, which is thirds. I know that 1 whole is the same as 3/3, and since I didn't have any to start, that's how many I have now. 3/3 minus 1/3 is 2/3, and 1 minus nothing is 1. So the first one you should have gotten 1 2/3. Okay, now for the next one, we're looking at 5 3/8 minus 2 7/8. I'm still going to ungroup because that's, to me, the quickest and easiest way. I've got 3/8 and I can't take 7/8 from it, so I'm going to go next door, borrow a whole, which leaves us with 4. I'm going to trade that in for the size of the fraction I need, which is eighths. One whole is 8/8, but I already had 3, so that's 11/8. And here's a little hint: if you just add the numerator and denominator, you'll always get what you need, the new fraction. 11/8 minus 7/8 is 4/8, and 4 minus 2 is 2. I'll simplify that. 4/8 can be simplified to 1/2, so you should have gotten 2 1/2 for the second one. Running out of room there. And then finally, the last one. We have got 2 1/6 minus 1 5/6. I can't do 1/6 minus 5/6, so I'm going to go next door, borrow 1 from my whole number. That leaves me with 1. I'm trading that in for the size of the fraction I've got, which is 6ths. I know 1 whole is 6/6, but I already had 1, so 6/6 more than 1/6 is 7/6. And now I can subtract. 7/6 minus 5/6 is 2/6. And 1 minus 1 is nothing, so I don't need to put a 0 whole number. I can reduce 2/6. They're both divisible by 2, which gives me a fraction of 1/3. There you have it. If there's anything that you didn't understand, go back, listen to the presentation again. Check out the other resources available for you on Schoology. Ask your friends and neighbors, and ask me for any help that you need.